Sweet. Well, the real reason Max wants me to do this for everyone is he wants to see what I'm going to present too. So if he does the breakout rooms, he can't watch what I'm going to say. Um, but hi everybody, it's been a little bit. Hopefully you all are doing well. Um, so I'm going to be giving a presentation today about TypeScript, which I know is something that a lot of folks have been asking about. At least when I was doing my section before, it came up a few times. Um, so I guess probably the best way to do this is just to get right into it. I should say that I have some slides prepared. Um, Kind of as I did it before, I'm just gonna kind of just jump into it and start talking. I have some stuff in the background to kind of guide me. But if you would all have any questions, please interrupt me and ask. Okay. So my slides, I will put that in the chat so you all can access that. It's a new link though, so let me just make sure that everyone can access it before I share it. Okay. If someone could click on that link and make sure that works, that'd be great. Okay, I'm seeing some people getting in the document, so I'm assuming it works. Excellent. Okay, so let me share my screen. Okay, sweet. So TypeScript is a typed superset of JavaScript that's created by Microsoft. So it's a lot of words there. So TypeScript is a tool that was built by Microsoft. And what it allows you to do is it allows you to write a language that looks a lot like JavaScript, but it's like JavaScript with some extra stuff in it. And what you can do is you take this new language called TypeScript, and you run it through this tool Microsoft built. I guess the tool is called TSC, but kind of also TypeScript. And so you run the language you've written through this tool that Microsoft built, and then out the other end comes JavaScript. So we're going to talk about some of the extra stuff that TypeScript adds in a second, but I want to sort of put that out there sort of initially to kind of demystify like exactly what TypeScript is. So it's kind of like it's two things. There's two sort of pieces involved. There's a language itself, which we're going to talk about, and there's a tool that will take the language you write and will convert it into JavaScript. So you can use TypeScript anywhere you would use JavaScript, both client and server and anywhere. I forget how far people are at this point, so I don't know what's been covered, but you can use it everywhere. You can use JavaScript. The main feature that TypeScript adds, kind of per its name, are what are called types. And types can be a useful tool to manage large code bases. I'm going to go through a little example here to explain kind of where these might come in and where these could be helpful. But if you've used other typed languages before, some of this should probably seem relatively familiar. Okay, so types. What is a type? So for those who maybe haven't come across this phrase before, a type is a kind of data you'd store into a variable. So some examples of types, like a string, a number, regular expression, Boolean, null, arrays. These are all sort of data types. In TypeScript, they sort of simplify that down to just the word type. Whenever you write JavaScript, when you are like defining a new variable and assigning a value into that variable, you implicitly are kind of giving that variable a type. Like if you do like const foo equals 5, then that foo value, that's got a type of number. But it's sort of just like built in a language. Like you create that variable, you assign the value to it, and then whenever you use that variable, sort of like it just the language just knows, oh, there's a number in that variable. But that's kind of where it ends. And while that works really well for a lot of situations, sometimes there are benefits that can go by going further than that. So I guess what I had written that was probably the better way of phrasing what I just said is types are implicit in JavaScript. So that means they're sort of like built in the language and they're not something you define. They're just sort of like you set a value equal to a variable and it's just in there. Variable casting, sort of. We're going to casting's a thing you do in TypeScript that's kind of similar. Let me get back to you with that question in like 10 minutes. Okay. I think it'd be good if we go through an example here to sort of explain like where these types can come in, how the types kind of work, and where defining types explicitly can be beneficial. So if you all remember from the section I taught previously, I had this little this function I was using all the time, set timeout, to talk about some asynchronous stuff. And really, I just needed a function to use as an example here, so I kind of reached for that again. So we've got this small little program here. I'm defining a variable here called const delay in seconds, and I'm setting that equal to the value 5. And then I'm calling set timeout. I'm giving it a callback parameter, and that callback parameter will log something once once the timeout completes. And then I'm passing it as a parameter into that set timeout, the second parameter, delay in seconds. So hopefully this should all kind of make sense to everybody, but just as a quick review, like what this is going to do is when I run this code, it's going to wait 5 seconds because delay in seconds is 5, and 5 times 1,000 is 5,000 milliseconds. So it's going to wait 5,000 milliseconds, and then it's going to invoke this callback and log out delay complete. So it should run it, wait 5 seconds, see delay complete. Okay, so let's do that. So 1, 2, 3, 4, 5-ish. There we go. Delay complete. Does what everyone hopefully expects. Okay. Now, this is all fine and good, but let's say you write this in some code, and you write this, and like a few months later, you come back to this code, and maybe you're not quite with it completely. You're like a little distracted. You're thinking like, oh, okay, I need to modify this delay in seconds, and you do something like you change this to be like the string long. You're just like, oh, I want to have a longer delay. Just put like the string long there. I realize it's a little bit contrived, but bear with me here. So I make this change. And now when I run my code, like I make my change, and I sort of expect, oh, the delay is going to be longer, or it's going to be different. Okay, so I'm going to take this, I'm going to run this code. Watch what happens in this case. That log prints out immediately, which like is not the behavior we would have expected. Like we would have expected like something more like I would have expected like an error to be thrown, or like this is sort of like a weird edge case. Like, I mean, looking at the code, you can probably see like string multiplying this by 1,000, like something weird's going on there. But the point I'm trying to make is like, this is a change that if you're moving quickly, you very easily could make. Yes, this is a bit of a contrived example, but you could change a value to something it's not supposed to be. And that could cause weird side effects in parts of your program that you sort of aren't looking at or have totally forgotten exist. So this is obviously, yes, the log shows up immediately. And I guess I should explain a little bit about why that happens real quick. So just if folks are curious, like why that happens is if I take log, and I multiply that by 1,000, I get this value, this not a number value, which is like a crazy JavaScript edge case thing. Exactly what that means and what's going on doesn't really matter. But the important thing is like this is being passed into set timeout, and that's causing it to do weird things. Okay, so because because we made this change and it was unexpected and resulted in unexpected side effects, unless we're really good at testing our code, it's possible that something like this could not be noticed and cause bugs later. So a big sort of fundamental idea with TypeScript is the idea that if you write your code in a way where you define your types explicitly, so as an example of that, let's say this, now we're kind of moving from JavaScript over to more of what you do in like a TypeScript world. What we do here in TypeScript is use this syntax, which I'm going to go a bit more into like how exactly you do all this in a second. But conceptually here, what I'm doing is I'm taking this value here, number, and I'm putting a colon after the variable identifier name. And this is how in TypeScript you say this thing, this variable, should be a number type. So what this will do is this says explicitly, delay in seconds must be a number. And imagine we made the same change again. If you well, actually, before I say this, I should say that like with this existing code, you take this code, you put it into the TypeScript compiler. And what it will do is it'll look through everything and be like, oh, okay, this is a number. Great, everything's good. And it'll give you, effectively, the JavaScript it'll output for you would look a lot like this. But it will take all those types out. However, if instead you give it what we did sort of our other case, sort of our like, we put the string there instead, something like this, and we give that to TypeScript, it's going to run on this code. The compiler is going to run on this code and say, wait a second, something's not quite right here. We've got number equals string, and it's going to say, there's a problem here. You need to fix that. What this means is, if you use a tool like TypeScript, a type checker, or in particular TypeScript, I guess in this case, like what it will do is it will make sure that where you explicitly say you want to have a certain type of value, that type of value must exist there. And it's all to make sure that you don't make mistakes, that you don't accidentally do things you don't expect to do and cause unexpected side effects in weird parts of your program. Okay, so before, I don't want to just keep running through this. I wanted to kind of give like an initial baseline, but anybody have any questions about sort of this whole scenario I'm outlining and where TypeScript can maybe be helpful when writing larger projects? Okay, so if nobody has any questions, I do want to kind of ask the group something, which is, does this seem like it would be helpful? Like, does this seem like it would be nice, like it would be beneficial in writing your code? And you can just give me a thumbs up or thumbs down, or if you want to elaborate, go for it. I'm just curious if anyone has any like gut reactions to this sort of idea of adding types into your program.
Well, right now it's so new for me, and JavaScript is also still new for me, even though we had like the course on it, but so I'm still just like, taking it all in, building some I guess like exposure to the language, the syntax.
Yeah, totally. And I'm going to talk about the sentiment you've mentioned a little bit later. So thanks for bringing that up, but totally makes sense. I know, Joe, in particular, you've been pestering me a few times on TypeScript. I'm curious if what you think about like all this, or if this is just review for what you've already looked at in the past.
I have experience with like Java.
Cool.
So like being very specific about what variable type you're using is very familiar to me. And it was very weird going into JavaScript and it being like, oh, it's handling it automatically, which most cases it's fine. I just did a project for school that I had to do like assigned to the calculator and getting it to return a specific decimal result. So like casting it as having the input from the console come as like an integer, and then I don't know, some whatever kind of function it's returning to like rounded to a specific decimal point or something. So I have more control about how the data is being returned or inputted that way. So, but that's my experience with it. It's about the extent that I have.
Totally makes sense. Yeah, I mean, one of the things that, I mean, for anyone who has a bit more, for anyone who has like more traditional typed language experience, what I'll say is the flexibility of data types in TypeScript, as far as like crazy different ways you can represent numbers, like all the different like sizes of numbers and stuff that you may be used to, that's not really there. Like the numbers in JavaScript are like IEEE floating points. that have sort of all the downsides of that. If you don't know what that means, don't worry about it. It's not important. But I think, Joe, you might know what I mean by that. So, and that can have some implications often. Actually, at work just this morning, somebody wrote a database table that had a column that had a key that was a 64-bit int, and I couldn't parse it into JavaScript properly. And it like wasted like 3 or 4 hours of my morning. Anyway, back on the topic. Okay. So here, this is kind of a relatively simple example of the kind of thing you can do with TypeScript, like what kind of value the tool presents. So I want to introduce a quick little thing that I think everyone could give a try and use it to experiment a bit around. And it's this website, typescriptlang.org/play. So I've got a link here on the slide. I actually think I've got it open here already. Yeah, I do. I'll reopen it though. I don't forget what state I left that in. Okay. So you'll probably see different text in the editor than me, but this is a nice little website because if you want to like play around with TypeScript and see what the tool can do, and you don't really have everything like set up locally in a way you can use it, you can sort of just play around with it in the web browser. And what's cool is whatever you write here over here on the left, you can actually see on the right here, this is the JavaScript that gets converted into. So just as an example, let's take our 2 things here. So I'm going to take this here, or our code example. I want to put it there, and you can see so that it says like delay in seconds number here. So you've got that number type alias or a number type definition right there. And then you can see over in the JavaScript it generates, it gets rid of that :number bit. So this code looks probably very similar to my first JavaScript only example. Let's try that long thing here, just to see how that would actually, what that would actually do. So I'm going to go long. You'll see a few things. You'll see that this editor shows a little squiggly red line under delay in seconds. If I hover over this, it says an error. It says type string is not assignable to type number. So that hopefully makes some sense. This is a string. This is expected to be a number. That doesn't work. Also see that shows up in the little errors panel over here too. And what you like, let's say I were to take this and be like, okay, let me change this to be a string. What you'll see now is the error no longer is on line 1, it's on line 4, because this might be a string, but if I take a string and I tried to multiply it by a number, that isn't allowed. So importantly, the way TypeScript works, it's sort of tracking the variable types through your whole program. And what that means is, if you update a type in one place, it'll sort of make its way through, and it knows the types of all the different built-in functions. For example, like set timeout. We're going to talk a little bit about like all the different syntax stuff going on up here. But like this is sort of the TypeScript definition of the type of this function. And because it knows this, it knows that like if I even tried to put like a string here, like that wouldn't work. It would just be like, no, I can't. A number has to go there in that second part of that function. Like that should be a number. So Joe says, could you cast an int or number and use the ASCII index? Yeah, you could do more complicated things like that. So the way you do that in JavaScript is char code or char code at something like that. Yeah, you could do fancy stuff like that. But that's sort of like you would have to really like do a lot of work to make that happen. It's not so I guess importantly, like this is mostly for Joe because you have more the background context on this, but like something like a char doesn't exist. Like you have a string and you have a number. There's no like single character data type. So there's no sort of like implicit conversion back and forth between that, like you would have in a lower level language like C. Or so something more like Java too. So like it's because of that, you have to, some of that implicit stuff you might be used to from lower level languages, it just isn't going to happen. Okay. So this tool here, I think is a good one for you all to know about. But probably where you're going to actually use this is going to be in the context of something like Create React App. So now that I've kind of talked a little bit about like fundamentally like what TypeScript does, sort of the type checking, how that fits into sort of the workflow, there's really two more things I'm going to cover for sort of like the rest of the class. The first thing is we're going to get this set up, like a TypeScript thing set up with Create React App locally, just so like you can try out TypeScript in a project. And then sort of like the second half of the class after that, I'm going to go do a bit more of a deep dive into like more parts of TypeScript. So we've talked about fundamentally like what it does. There's a lot of syntax that I want to get through. And once we actually have a TypeScript Create React App thing running locally, we can use that and sort of start to play around with all those complicated syntax stuff. Okay, before I get into that, any questions?
Yes.
Yeah.
So in that TypeScript example that you had on the slide, so the only piece of syntax that's like exclusive to TypeScript is the word string and number. Everything else is just JavaScript.
So it's from what we've learned so far, yes. Now, there is more. We're going to talk about that in like 20 minutes. So we're going to get there. But for now, the only thing we've talked about that you can do in TypeScript is if you have a variable and you want to explicitly say what type it is, you can put a colon, space, and then the type you want. And we're going to talk about like all the different type options. We're going to talk about like way more about that. But before we can really do that, we have this little playground site and we can play around with it. But I want to get you set up with a local environment so you can actually like play around in React with all the other tools, because folks are going to run into problems, and there's a lot of fun TypeScript problems. So I want to like do this in a real environment so that everyone can experience the fun themselves. But yes, the only thing we've talked about so far is defining a type annotation on a variable declaration. Sorry, I should have just went for that. I shouldn't have elaborated so much there. Okay. Any other questions? Okay. So I'm assuming I'm just going to assume that everyone here has a base knowledge of Create React App experience. I'm pretty sure that that's already been covered. Okay, Bax is nodding. Good. So when you've kicked off Create React App to create it, what sort of command have you used? The npx thing, the npm create thing? This is mostly a question for Max.
npx create React App.
Okay, cool. So this, what I have selected here probably would look pretty familiar to most of you, I think then. With Create React App, I'm going to new window here, and then actually I've got so I'm gonna start, and if you all can follow along, that would be great, just so we all can have an environment running locally that has TypeScript, everything ready to go. So I'm going to go through it here, and then if anyone has any questions, I can sort of go through parts of it again. So I'm going to start by just making a directory to stick my Create React App project in. I'm going to call it TypeScript example. And then I'm going to run npx create React App TypeScript example. And there's a parameter you can pass to Create React Apps. Remember back to what we talked about when I was doing all the networking stuff, you have sort of your command line flags you could pass to command line programs. And there's a flag you can pass called template TypeScript. And if you pass this parameter to it, what the Create React app will do is when it sets up your new application, it'll set it up with a bunch of TypeScript related stuff in there and make all your things by default TypeScript. So I'm going to hit enter there. I'm going to let this run for a little bit. This command, if folks didn't see, is on the slide deck, so you can copy and paste that if you need to from there. Okay. And real quick, I'm just realizing I gotta stop something else running. It's gonna steal the port I need. One moment. Um. Yes. Okay. Okay. Once you've gotten this command run, if you could give me a thumbs up or a message in the chat, just so that I know that everyone's gotten this far, I would appreciate that. I'm also gonna CD into my TypeScript example directory too, so should have that all set up and ready to go. Okay. Unless anyone wants me to wait one more moment, I'm probably gonna to move on here. Okay. So, I'm going to CD into my TypeScript example directory too. So wherever you put your app, make sure you go in there. And to start with, I'm just going to do what it says. So I'm going to run npm start just like I normally would to kick off that application. Ooh. So I'm going to go over here in my web browser and go to localhost 3000. Okay. Ooh. Actually, I do want to keep that open, I think. Okay. Sweet. So I have my create React app thing running. So that's all great. So let's take a look at what this actually created and see where it differs from what you've probably seen normally created as part of the regular JavaScript create React app. I'm going to use a quick command. You may or may not have encountered it before, called tree. And what it'll do is it'll sort of print out the whole file tree. Oh, I guess it's just one deep, so it's not very exciting. Okay, the first thing I want to point out is if you look at this, you're going to see that instead of having .js files and .jsx files, you now have .ts files and .tsx files. So the difference there is .js files are for JavaScript and .ts files are for TypeScript. So in order to get a create React app or pretty much any tool to process a file as TypeScript, you need to give it a .ts or .tsx extension, just like you have the JS or JSX file. Okay. I think at this point, I probably need to open this in the VS Code thing so that we can take a look at this. File, let's see, open folder, yeah. Okay. So let me get my C folder back over here. So inside of here, the first file I'm going to look at is index.tsx. Now this probably looks pretty similar to what you're used to seeing with a root create react app index.jsx file. There's a few small differences though. Probably the one you'll notice immediately is has HTML element. We'll talk about what that does in like 20 minutes or so. But importantly, like this probably looks relatively similar to what you'd expect. There's not going to be a ton of differences. Want to see if there's, okay, yeah, cool. So also not that much of a difference with the app.tsx. Sorry, it's I'm re-looking at this stuff again too because it's been a moment since I've used Create React App. I've used some other tools more professionally more lately, so I'm kind of forgetting what it puts where. So bear with me a little bit here. Cool. Okay. So to start with, I'm going to start my dev server again in my terminal just so I have that running. Okay. So let's do our example from the slide presentation. Let's do it in that Create React App repository just to sort of see how it handles like type errors and type problems. So we talked about it kind of in the playground. But let's do it actually in a project. Okay. So what I'm going to start with is I'm going to start with just this regular code here. And I'm going to take this code at the very top of my index.tsx file. I'm going to paste it. And when I save this, should see, yep, delay complete. So it does the same, what we'd expect. It shows the delay log after 5 seconds. There's a few things I want to call out here. First of all, notice that I didn't explicitly define a type on this. Like I didn't have to. So a core thing about how TypeScript works, and it's relatively important, is that TypeScript is opt-in. So by default, with the way TypeScript's configured by default, any valid JavaScript is valid TypeScript. So what you can do is you can write your sort of like, take your JavaScript and give it to TypeScript. And because there's no type annotations, like it doesn't know any types of anything, it's just like, oh, okay, well, I don't know the types of this and I don't know the types of that. And because it isn't able to check anything, it's just like, yeah, okay, this seems fine to me. So TypeScript, it's opt-in. So you have to sort of like add the type annotations if you want them. And this has pros and cons, but it's just sort of like how TypeScript has been built. So let's add in that type annotation here on number. So notice I do that, and we still get the same behavior. So wait 5 seconds, you get that. So that works great. Okay, let's change this to a string. So now you'll see that VS Code has, because VS Code's also a Microsoft product and it works together with TypeScript, a Microsoft product, yay, vendor lock-in, it will highlight delay in seconds in the editor and tell you, oh, there's a type problem here. So that's what will end up happening. And if you save this, when Create React App, like when you save it, Create React App will try to compile it and will actually give you an error in the browser. It'll say, the types don't match. You can't run this application until you fix that type error. It'll also show it to you in the terminal in the developer console. Okay. And if I now go through the same thing of like, let's say I change the type, just like before, the type kind of changes, it ends up following its way through the whole thing. And that's, so, okay. Anybody have any questions about getting this all set up locally and what's required to make that happen? Okay, sweet. So now we get into the majority portion of today's program, which is let's talk about all the sort of like things you can do with TypeScript, all the different like syntax primitives and how they work. Okay. So I have a big list of these, of things I definitely want to cover, and then we'll just kind of see how it goes, and I might drift off into other things. You probably all know how it goes with me sometimes. Okay. So the first thing we talked about, I'm gonna get rid of this. We're gonna start fresh here. So we previously talked about you can define a number, or you can define explicit type assert or type annotations on variables. So if I do const A, const B, then B is a number and A is a number, and doing something like A plus B, or actually maybe the better way to do this is C is equal to A plus B. It knows, oh, C must be a number. And if I did something like, let's say, made this a string, then it's smart enough to know, oh, this is going to be a string. Because if you add a number to a string, it's going to concatenate it onto the end and sort of add it to that long string and sort of combine it together. So this, for anyone who's used a typed language, this should seem very familiar. This is sort of typically how you tend to work. There are a bunch of other primitive types, though. So string number, we've also got Boolean. So it does probably what you'd think. So in this case, this is going to be an error, well, because you can't find B, but that's going to be an error because you can't add a number in a Boolean. But if I did like maybe A and B, then that'll work. So Boolean, what are some other primitive types I wrote down? Yeah, arrays and objects. So the first way we're going to talk about defining arrays and objects. So just like you all are probably very familiar with arrays and objects at this point, but an array being a data type that has a number of items in it that are sort of like that have an index. So you've got like a list of values all referenced by index. And an object being a value where you have a bunch of different keys that are sort of referring to values in that centralized store. If you want to create an array in TypeScript, the way we're going to talk about first is a few ways. Is if you take any primitive data type and you put open close bracket after it, that becomes an array. So now if I do like, or actually I guess I got to make the strings, 1, 2. So now this is an array of strings. And that's sort of how you'd represent that in TypeScript. If you wanted to make like a 2-dimensional array of strings, what you would do is something like this. So you'd have like 1, 2, 3, something like that. Note that this in JavaScript, arrays don't have a fixed length. So for some folks who are familiar with type systems in other languages, an array you sort of define as part of the type, like the length of the array. And here, like because arrays are actually like linked lists in JavaScript, you are defining like just this is an array, this is like a list of items, and that's all you have to define. So just like this is an array and that's it. There's also, actually, I'll keep that around there. There's also objects. So there's 2 ways you can define objects in TypeScript. The first way is, let's say you want to define an object where the keys are all one type and the values are all one type. So imagine you have like an object where all your keys are arbitrary strings and all your values are arbitrary numbers. So it's just like string map to number, string map to number. And that's as much detail as you want to give TypeScript. The way you do that is you use this. There's a syntax sort of that that they've given where you do something that kind of looks like this. So what this says is I've got an object. This thing here is the key, and it's a string. And this is the value, which is a number. So if I were into here, going to do something like foo hello, it's going to even be the red line because hello is not assignable to number. I'm actually going to, I think, go C, D, and then string. I'm going to try to do this in more of a depend-only way so I can copy and paste this when I'm done. Okay. So what you really would need to do here in order to get this to work is you have to give it the string and a number. So got to give it foo1, so a number like that. Or I could put a string there. So because this now matches this, it's good, but this doesn't. So you have to make them line up. Okay. Cool. There's one more representation I'm going to talk about for objects that's kind of helpful. And that's if you want to have explicit keys and values. So importantly, with what we've defined here, I have key is a string, any arbitrary string. And then value is any arbitrary number. What if I want to define an object that has like one literal key of the value like hello and one literal value of like a string? There's a way you can do that in TypeScript too. So this is a sort of another way you can do it that gives TypeScript even more information about your object, so it can better verify that the value you placed in there is correct. And what you do there is something like this. So in this case, now my type here, I'm defining has a literal key hello equal to a string. So you can see here I got the red squiggly line because foo is not in hello string. But if I were to make this hello, still get the red line, but now it's for a different reason, because number here is not assignable to string. So if I finally were to make this like that, now I wouldn't get any type error because the key hello is mapped to the value of a string. Okay. There's one more primitive we're going to talk about, but before I get into that, any questions on any of these? Okay. The last primitive we're going to talk about are what are called literal types. These I'm going to talk about a bit in a second because they can become really powerful and really important. But in TypeScript, you have things like making a variable of a type like string. But what if you want to make a variable of a type of like just one string? Like maybe you want to allow a variable to only be the string test. You can do that. And this is sort of where TypeScript starts to diverge a bit from other type systems you may have used in other languages. It has some, it goes a bit deeper than type systems that tend to be around mostly for like memory management. So sort of more of like the Java C sort of type of stuff. So what I can do is if I did like this and I went test, test that. So literal strings or like a literal number. So I'll do the literal number here just as another example. So like these work as types. And what this type means is like not just a string, but only this particular string, or not just a number, just this particular number. And you might have seen it briefly before, but if I try to set it to something else, it's not going to like that. Okay. Any questions on those type literals? I think at this point we've covered all the primitives, and we can start to talk about like more interesting places where these can be used. Okay. So I'm going to start by just labeling this primitives. So we've talked about using type annotations to annotate a variable. There's a bunch of other places you'd want to use types too. The next one we're going to talk about is types in functions. So you've all probably defined tons of functions at this point. I'm going to make a function called add. I'm going to give it 2 parameters. I'm going to return a plus b. I'm going to console.log 1 plus 2 equals add 1, 2. So hopefully this should all make sense to everybody. And if I go over to my app, you'll see, oh, yeah, okay, it's gonna, interesting, it's gonna give me that. Okay, we're gonna get to that in a second. I didn't realize that create react was configured that way. So it gives me 1 plus 2 equals 3. So kind of what you'd expect there. Okay, so this here is JavaScript. There's nothing fancy, nothing TypeScript related I've added to this. But kind of on the theme of what we talked about previously, there's nothing right now that keeps you from doing something like this and getting like this. I want to ensure that only someone can only pass numbers as A and B into add. So the way I'm going to do that is, you might be able to guess, just kind of like variable type assertion above. I can put things here. So I can go A is a number, B is a number. And then when I do that, 1 plus 2 equals 3, that still works fine. And then if I do something like this, it's going to give me an error because I can't pass a string into my add function. Cool. So one other thing I want to quickly mention, which is this add function, actually automatically, like TypeScript knows that it returns a number. So I could explicitly define a return type here. It's sort of if you want to sort of define the type in the definition, you can put it there. But TypeScript knows how to do that without having to like requiring you to define it there. And the way it knows that is because it knows that if you take a number and you add a number to that number, so you do number plus number, you're going to get a number. So it knows this expression here evaluates to a number, and a number therefore being returned. So therefore, it knows that a number is the return type of the function. So this sort of behavior, tracing that type through, is something that happens all the time and that you are heavily reliant on in TypeScript. You can also imagine that if you didn't have all the fancy developer tools, that becomes kind of tricky. But we're going to get to that later. Okay. Any questions on, I'm actually going to explicitly define this here just as in our example so you can see that. Any questions on annotating types in function definitions? Okay. What did I have next? Yes, any. Okay. So there is one more important type that I haven't touched on yet that I want to make everyone aware of. And there's this type called any, A-N-Y. So if I make a new value here, and I annotate it with the type any, and I give it like equal to 1. This any type here means you can put any value you want into this variable. So this sort of is like the behavior you typically have in JavaScript. And in fact, if you are writing JavaScript, or like if you're writing, I guess it's a better way to say it is if you're writing TypeScript and you don't define a type annotation on a variable, and TypeScript can't easily figure out what the type of that variable is, it'll make your variable by default the type of any. So what this any value does, it's kind of it's very powerful, but it can be misused very easily. So what people often do when they start using TypeScript is they run into some sort of complicated scenario that they're not sure how to deal with. And what they do is they say like, okay, I can't figure this out. and they just make a variable of type any to get an error to go away. If you imagine, like, if you have a type error and it's because like this type doesn't line up with this type, a very easy way to make that go away is just be like, oh, we'll just change one of these types to any, so it'll always line up perfectly. So that would be like here, if I like had this type error, and instead of actually fixing this, I just went here and I made this any. Like, that makes the error go away, but it means that like you are encountering sort of unexpected behavior. So typically it is recommended that you avoid using any where you can, where possible. In fact, it's you might have noticed before that when I hadn't defined these types here, that it actually would give me an error. So it used to be TypeScript was set up in a way where like they had what's called this value called no implicit any was turned off. And what that meant is like you could just take your JavaScript and just put it at it and it would just work because it would just assume all your variables were typed any. And these days, that's not really recommended as much anymore for this kind of problem, where because it ends up hiding errors unexpectedly. So because of that, they've like people have generally with time moved to turning on this flag. You can turn it off if you want, but it's just like typically people turn it on. And what that means is if any newly written code you write, you've got to define types in it. TypeScript won't just assume any if that flag's turned on. Now that doesn't mean like keep in mind though, you can actually explicitly say something to any. So like if I wanted this to be any, like for some reason, I could do that. That's fine. It's just it's important to not conflate like any meaning I really want any value to go there, and any meaning I'm putting it there to fix a problem, to hack around something because I'm lazy. Those are sort of like different things. And the former is what any is meant for. The latter is not what it's meant for. Okay, any questions on any? Okay. There is one more thing I'm going to mention about any in a second, but we got to talk about a new concept before that, which I think I'm actually covering next. Yes, I am covering next. Excellent. Okay.
Actually, Ryan, I have a question about any.
Yeah. Yeah.
So any is just could be like any like anything like a string, like an integer, like anything like that.
Yeah.
Is that correct?
So let's do something like that. So these are both totally valid. And if I went here and I was like, I made this like number now, that wouldn't be valid. But any means like you can put any value you want into that variable. So it acts just like you would, how it would work with JavaScript.
And you said you don't like recommend us using like any.
So where you should use any is if you have a place where you actually want someone to be able to put any value there. So someone can put like, here's maybe an example. Imagine you were writing a function, the console.log function. You were sort of like defining your own implementation of that. And you wanted to allow someone to pass whatever they wanted to that console.log function. You wanted them to be able to pass like a number, a string, an object. That's a situation where using any makes a ton of sense, because what you want to do is you want to allow someone to give it anything. What you don't want to use any for is you don't want to use any in a situation where you should actually use a more strict type, but you're using any just to be lazy because you don't want to figure out how the types work. And that's something that you might say now, oh no, I'll never do that. I'll use the tool. But I can just tell you that working in a lot of code bases, this happens a lot. And I'm going to touch on in a second. I actually have a trick that I've started using that actually I think has made a big difference, that makes this more tenable. But we'll get to that in a second. So does that make sense? Cool. Okay, so the next thing we're going to talk about is what are called custom types. So think of a custom type as like what you would do when you define like a variable. So I have like in JavaScript, I define a variable like this. And what I'm doing is I'm defining this sort of variable, and anywhere I use that variable, it's now going to be equivalent to 1. Think of a custom type as the same idea, only for a type. So let's say, and if folks have more experience with like typical type languages, the phrase like a type alias is sort of the same idea here. So what you would do is to define a custom type, instead of using the const or like let or something with a variable, I use the phrase type or the identifier type. And then typically when you make custom types, you make them in Pascal case. So like the same case you'd make like class or a React component. So like uppercase camel case, upper camel case, I guess is the other way you might say that. So I'll go like custom type and then make that equal to, let's say, like string. So this custom type now, anywhere I want to use a string, I could also use like custom type. So something like this is like would be a valid use case. So in this case now, like I'm not defining string explicitly here, but like it sort of is able to trace through and know, oh, custom type that was defined here, custom type's a string. So therefore I can assign foo, I guess I should make this a little bit less confusing. I can assign bar to foo because bar is a string and foo is supposed to have a string in it. So this is another one of those cases of TypeScript kind of like tracing its way through and figuring things out, and it being really important to be able to follow that where it's going. Okay, why would you want to do this? So a great example is, let's say you have a similar reason as why you might define like a constant in a program. You have a value that you want to use in a bunch of places, but you don't want to define it in that place over and over again. And if your value in that case just happens to be a type, you have a sort of like you want to use a string in a bunch of different places. And let's say that string is like a value where it might become a number in the future, and you want to sort of have one centralized place you can change that, have it update everywhere. You might use a type alias or a custom type for that. So similar to the idea of like a constant, only for types. Any questions about custom types? Okay. So yeah, go for it.
So it's not really a question about like the custom types, but it's more of, because you mentioned like for those who's like familiar with type languages, like can you like describe like what a type language would be?
Yeah. So I'll be clear, I'm mostly saying this for Joe's benefit. I don't know if anyone else has experience with this stuff, but I'm trying to sort of draw some parallels. But a lot of languages built into them have a type system that's explicit. JavaScript doesn't have like an explicit type system, but for some examples of like other languages, things like C, Java, Go, Rust, gosh, what other stuff is there? Haskell, all the like functional programming crap all has that. Yeah, so like, but typically in a lot of programming languages, especially ones that were maybe earlier, like are not sort of more modern, things like a C is a great example. The type system really exists in C primarily for memory management. So like in something like C, what you actually do is like you say, I want to define an integer, and this I'm going to store into this integer a value. Maybe I want to store like 1 into my integer. And in C, you know, oh, an integer, this is like a data type that is like a certain size in memory. So integers typically are 32 bits long. So what you do is like when C actually compiles your program, it is able to look at those type definition or type, yeah, I guess like type definitions and say, oh, that is how big this should be. So like when I actually behind the scenes run the code and like compile it and turn it into the actual like underlying machine code, it knows, oh, I need to allocate this amount of space for my integer. I need to put it there. Or it's able to use sort of that to do all of its internal bookkeeping. Something like JavaScript doesn't really, it works at a much higher level. So yes, all that memory management has to happen behind the scenes, but in JavaScript, that's something that's built into the language. So what it's doing, to be clear, like instead of it actually being like, oh, this integer is like this size of memory, what it does is it is able to dynamically allocate memory in a less efficient way for every variable as it gets defined. So something like in C, what it's able to do, I mean, you are sort of still kind of, in some cases, dynamically allocated memory, but I'm going to hand wave some stuff away at the moment. But like in sort of like classic stack-based C, like what you're doing is you're defining like fixed lengths of things, sort of putting them onto a thing called a stack in memory. And in something like JavaScript, what you're doing is, as the program runs, it's sort of being like, oh, okay, I got to define this variable. Let me sort of do all the computations and be like, okay, this variable, I need to put this in it. And what it will do is it'll sort of like figure out how big it needs to, where it needs to store all that, and sort of like put it all in the right places dynamically. So it doesn't need to know necessarily like how big that data structure is at compile time for memory management, because all that isn't happening at compile time like C, it's happening at runtime in JavaScript. So I could really go down a rabbit hole here, and I'm trying to avoid like going too far down, but hopefully that makes sense.
Yeah, that makes sense.
Yeah.
Now I have a like question about like the custom types.
Yeah.
So I noticed that you have like type and then custom type and equal string. Is that where we could like just like I guess I'm trying to find it, like I'm trying to how to say it. Is it do we have to use like the custom string, or rather like would you recommend us using the custom like type?
Yeah. So here's a we're going to go through some more examples in a second that are going to maybe give you some better uses for them. But I would say at the point we're at now, you can think of them being used similarly to how you use constants in code. So let's say you have like a variable or a value that you're using in your code in a bunch of places. It's sort of like one constant value. What you can do is you can define that constant at the top of your program, set it equal to a value, and use that variable everywhere. And then if you want to change that value, you have one place you can change it. Think of the same idea with a custom type, where you can define this type at the very top of your program and say, custom type is a string. And then write all your code and use custom type all over the place. And then if you decide, actually, I want to make custom type a number, you can change it in one place and the type will cascade through your program, just like you would with a constant. Does that make sense?
Yeah, that is so cool.
It's cool. It can also really give you a headache. We're gonna I'm saving for the end. I have a lot of thoughts on TypeScript as a tool. I've been using it professionally for like over 5 years now, and on teams, and seen it both go really well and really not well. So I'll have some stories to tell later, but that's for later. Okay. So I mentioned before with this whole any thing that there was a technique I've developed that I really like for like solving that whole like using any because you actually want to use any or using any out of laziness problem. It's something that at Density we started doing as a team, and I really like it. So what we'll do is when we make a project, one of the first things we'll define is a constant type, custom type somewhere that looks like this. We call it fixed me, usually. That's what we did at Density, but you could kind of call it whatever you want. And the idea is anywhere you have anywhere that you have a like a function or some sort of type definition where crazy function. Anywhere that you have like a value where you actually like don't know what the type is and like kind of don't want to figure it out due to laziness, using this fix me pattern, you use that instead of any. And what's kind of nice about this is it means that you can search through your whole code base for fix me and find every place where you've like actively chose not to use type, and it makes it really easy in the future to go through and like fix that stuff. So sort of like this is like it's not something that someone like taught me. It's just like we figured it out on the team and it worked really well. But this is sort of a pattern where if you find yourself wanting to use any out of laziness, I'd encourage you to try something like this instead, because it disambiguates the notion of like anything can go there and I don't want to figure out this type problem right now. Okay, just wanted to quickly touch on that because I think that I really like that pattern. I've used it like on a lot of teams now, and it's gone well. Okay, cool. So what's next? Yeah, I'm probably going to be able to get through more than I thought I was going to. I kind of kept this list conservative, but we're going to be able to go deep if folks want. So type assertions. Okay. So Joe, you had mentioned earlier, it's sort of like casting. And I said, kind of, we're going to get to that in a second. So this is where we're going to get to that. So in TypeScript, I guess I should, before I get into this, I should explain what casting is for everybody, just so they know. So in a typed language, you often have the problem of you have a variable of one type that you need to convert into a variable of another type. In many typed languages, what's actually going on behind the scenes is like it's doing some sort of memory tricks to make that work. But so like what you need to do is you need to somehow like convert that value from type A to type B. Every language is a different way of handling this, and this is actually kind of a tricky problem because sometimes casting from one value to another, like converting the type directly, will result in weird data because it's sort of like trying to do its best, the programming language, and often not quite doing it right. So sometimes you have to sort of write your own functions to handle the conversions properly. In TypeScript, so I guess like that's what casting is, sort of in a typical type programming language context. TypeScript has what's called type assertion, and that's the closest thing you have to casting. So type assertion is if you have a variable of one type and you want to convert it to another type. Now, so this is similar to casting, but the important difference is type assertion only happens at compile time in TypeScript. So TypeScript runs, it removes all those like variable annotations from like the variable declarations here. Like it removes like any, it'll remove like the custom types and all this stuff. It'll strip all that stuff out. It will also strip out type assertions. So that's why they're not called casts, because it's not actually casting. There's nothing happening at runtime. This is purely a compile time TypeScript thing of being like, in TypeScript, I want to take this value of type A and convert it to type B and sort of like tell TypeScript, actually, this value of type A is actually type B. If you write your TypeScript perfectly and there's like nothing complicated, you almost never need to do a type assertion. It's a relatively rare thing in perfect situations, but as you all can probably guess, perfect situations themselves are somewhat rare. Things always come up that are weird and unusual, and casting is sort of a good tool to be, or sorry, not casting, type assertion. Gosh, I'm getting it all messed up now. Type assertion is kind of a good tool to have in your tool belt to get out of some of those crazy situations. So, what type assertion looks like is, let's say I have like const A number is equal to 1, 2, 3. And then I have const B string is equal to A. So if I do this, oh yeah, I also can't reuse my variables. Where did I end at? H, I, okay. And then H. So if I do this, it kind of like, so I'm defining H, that's a number, 1, 2, 3, that's all great. But I'm taking I here, and I is a string, but I'm taking H and I'm trying to put the number into that string, and that doesn't work. If I do H as string, oh, and maybe this isn't going to work. Let's see. Yeah, okay. I want to do a different example because I want to talk about what this error says, but I don't want to start there. Let's do something like this. Yeah, there we go. Okay. Will that work? Yeah, okay, this is gonna be fun to try to show because what's a good example of what I can do here? Give me a second, folks, to think about this. I mean, I can also just talk about what's going on. So I'm the challenge here with this, with like this kind of example, or wait, I want number, is I'm trying to do a cast here or a type assertion here, but it's not like what I'm trying to do with TypeScript's like, this makes no sense. So like it's saying like, I'm trying to convert this number to a string, but like that, you can't do that. Like there's nothing in common here. This isn't allowed. I guess one thing I could do is I could do this. Oh, look. So in this case, I'm able to like convert h to any, and now I like this expression evaluates to any where this is now a number. So I guess that's kind of a positive example there. But the challenge with type assertion is like sometimes TypeScript won't let you do it because it's like this is just such a crazy situation where like I don't understand how you're making this conversion happen. So sometimes you have to do is something something like this. So like if I wanted to actually make J a string, like what you have to do is do it in 2 steps. You have to type assert H as any, and then once it's any, once it could be anything, then you can be like, okay, TypeScript, now any, I can convert any to string, and that's fine. So it's like, it's goofy, like it's a good tool to have, but it requires sometimes some trickiness to get TypeScript to do what you want. Yeah, I think that's where I'm going to leave it. It's good to know that it exists, but like, and it's good to know that it's kind of like the equivalent of casting in other type languages. But it has a lot of complicated dynamics that take you a while to wrap your head around. That I'll be honest, I only kind of know by intuition. Like I haven't actually like really been able to fully learn. Okay. That's type assertion. I might come back to that once we've got some other examples under our belt, because I think I can do another demo once there are have a few more concepts. So I'll for now, that's where we're going to stop with that one. But any questions about type assertion based off my kind of iffy explanation there?
No question. I did post my it was just a snippet from my Java homework that might get in the same kind of ballpark where you're working with integers and then dividing them and then changing the type of the result to show the correct thing, which might be a little more straightforward to understand.
Yeah. Yeah, I would for folks who maybe are curious, like that's maybe another example. The unfortunate thing is I can't do that in JavaScript because there's only one number type. So like there's not really like number precision is very fraught in JavaScript. And
well, that's disappointing.
yeah, like everything is an IEEE float. So like rounding errors are a problem, and like handling money can be a problem. Like, yeah, it's a problem. But you often actually have to effectively, like, if your precision's important, end up like building your own little fixed point engine where like you sort of like store everything as whole numbers and do all the division. Anyway, hopefully, Joe, you might know what I mean by that, but like it's fun. Okay. What's next? Ah, yes. Okay, this is gonna be a big one. So type composition. So far, we've talked about purely just like primitive types and some places you can use them. Talked about how you can use them in variable assignments. Talked about how you can use them in function declarations. However, in the real world, types end up being a lot more complicated than just like primitives. You have like arrays that contain like objects that have like mixtures of keys, and you have all these crazy situations you have to try to represent. And TypeScript gives you some tools to try to do that. I will say, I have yet to come across a situation that TypeScript can't represent with the caveat that that I've actually been willing to put in the time to figure it out. So I have, in many cases, completely just been like, I don't want to figure this out. Or in many cases, like, I don't have the time to figure this out if I'm on a deadline. And that's that. But like for everything, like the type system that TypeScript provides is quite flexible. And a lot of what I'm going to show in a second is kind of what gives you a lot of that flexibility. So there are two sort of really important operators you can perform with types. So just like you have operators like plus and minus and times and divide with multiply and divide with like numbers, the sort of operators you can apply to types. Both of these are unary operator, or sorry, not unary, binary. Yeah, I guess binary operators. So you've got sort of like one argument, the operator, and then another argument. Just like a plus, for example. The first one we're going to talk about is what's called a union. So I'm going to make a type alias here, a custom type example union, and I'm going to set this equal to number. Okay, should hopefully be pretty straightforward. However, let's say I want example union to be, I want to represent, say it can either be a number or it could be a string. Well, you can do that. I can use the pipe operator. Yeah, sounds like set theory. We're going down that rabbit hole. If anyone has like functional programming experience with something like Haskell or like gosh, like Lisp or something like that, like this is sort of, there's a lot of like similarities to some of this with like you can sort of like formatively prove your program is correct if you're into that stuff. Yeah, go ahead, Joe.
It's seeming like as you're demonstrating this, it seems like somebody really wanted to die on the JavaScript hill instead of using like a lower level language.
Yeah, I would agree with that. Although keep in mind that something like a web browser, you don't really have many other options in JavaScript.
Oh, that's right. They built the whole system around JavaScript, and then instead of changing the infrastructure, they changed it. I gotcha. Is that
Yeah,
kind of what happened?
yeah. I mean, you've got JavaScript in a web browser, and it's been around for like 20 years or whatever. So you can't like you can't make changes to it. So instead, you make changes to the tools that output it as like a compile artifact. That's kind of the idea. Okay, so getting back here to our union, so we've got number or string. You can see here that example unions, string or number, I guess it flipped the order. The union's sort of a commutative operator, so the order doesn't matter. So if now I make like a variable and I set this to example union, so it's the type, I set it equal to a number. Oh, and I need to not redeclare my variable types. Example, I'm going to run out of names soon enough. So example here, it's a number, totally fine. I have a little red underline. That's good. I can also set it to a string, and that's fine. But note, I can't set it to a Boolean. I got the underline there. Or oops, I can't set it to a Boolean. That's what I meant. So Boolean's not assignable to type example union. And you could sort of trace that through and be like, oh yeah, it's because it's not in there. And I could also do something like add a Boolean to that, and now all of a sudden that Boolean's in that union, so it's good to go. Okay. So that is a type union. there is another operator, the other one we're going to talk about, that's what's called a type intersection. So you can think of union as sort of like the sum, the combination of all the different types you give it. Intersection is the things that are in common between those types. And in order to explain that, I want to do one more union example because I'm realizing that I can't really do an intersection example like numbers and strings. So a case where you might use a union, let's say I have an object like this, and I do a union with like foo bar. So what this ends up resulting in is it can have sort of like either representation. So if I did like yeah, something like that. Like that works. And then if I did hello world there, that would work too. The reason why I'm doing this is if I did something, let's say I change this from foo to hello, just to something like that. Okay. So in this case, what I'm saying is like example union 2, I can either set it to be this or I can set it to be this. Actually, I'm gonna do one more thing in here. I'm gonna be like, okay, I'll do that. Yeah, like AB. So sorry, I'm trying to make this up on the fly. Bear with me a little bit here. Okay. So that's one thing it can be, or that's the other thing it can be. So either it can be an object with key of hello, value of world, key of A, value of B, or hello bar. So here's our first type. Here's our second type. You can see either works fine. Okay, sweet. Now, intersection. This is in this sort of object case, which comes up a lot. This is sort of becomes really handy. So I'm going to do one more thing here. I'm going to abstract this and call this like example union bit. My naming is going to suffer here. Bit. Okay. I guess I didn't cover this explicitly too, but like I can use type aliases, like I can, this is totally fine. Like I've got a type alias, I'm using that over here. I'm just like a variable, I can sort of plug that in wherever I want. Okay. So I've got here my little like example. Let's, I'm going to take this and I'm going to copy this. I'm going to paste it below. I'm going to make one change. I'm going to also just quickly, I'm going to update all these unions to intersection. Just to make sure that section intersection insert intersection. There we go. Wait, I think example intersection that. Yeah. Okay. Example there we go. Okay. Okay. So for intersections, the only thing I'm going to change this pipe here to an ampersand. And you'll see that sort of changes some semantics about what's going on. And I might have screwed this up. Let's see. One moment, folks. Um, yeah, I did screw this up. I think that's really what I wanted. Yeah. That's it. Oh gosh. So what I am going through right now is a very common experience with TypeScript. I'm glad that this is happening. You can see it organically how what you can do here. So right here, I would call this a type puzzle. That's kind of the phrase I tend to use for it. So I have given myself here a complicated problem that makes me have to think a lot about how all these types work. And you often learn when these type puzzles how little you actually know about TypeScript. So these the reason why I find these kinds of things a little frustrating is because fundamentally I just am trying to get my code to work, and I just want to make I just want TypeScript to be happy and get out of my way. So I'm trying to think about why this isn't working as I would expect. So what the type intersection operator should do, let me at least start there. And then maybe if you all see something, you can point it out. What it should do is if you have two types, it'll sort of take the parts of the types that are different and like combine them together. So this will allow you to do either hello world, AB, or hello bar. What this should do, for some reason I can't get it to work right, is what this should do is it should combine all these together. Actually, I know what I can do. Do something like this. Yeah, there we go. That's what I meant. Okay, excellent. Okay, cool.
And
So-
Ryan, just a reminder, it's close to 7 o'clock, so if you hit a good breaking spot coming up.
Yep, I saw your note. I'm going to finish this up. Give me like 2 more minutes. Leave off a nice confusing note for everybody. Okay, so this intersection thing, what this will do is you give it 2 objects. Typically use this with objects. I think you use it with other things. I have not really found myself using it in other situations. And what it will do is it will sort of combine them together. So this first object intersected with the second object. The result of this, okay, it's not going to simplify it in there, but the result of this is now I have to specify all 3 keys when I define it. So I just do 2, that doesn't work. I just do that, this doesn't work. So that's kind of what type intersection does behind the scenes. Out of these 2, I use union like probably 3 or 4 times more often than intersection. It's good, like intersection's important, but it's definitely the less important of the 2. Okay. Any questions on intersection? Gosh, I can't believe this really was not a great explanation. We're gonna next after the break, we're gonna talk about discriminated unions, and I think that'll we'll have some fun use cases of these combined where maybe it'll make more sense. Okay, one more minute. One other thing I want to talk about, and then we'll take our break. So in the past, when we've had sort of like type errors with some of these above here, for example. Oops, I mean like a Boolean. So these are relatively straightforward. Like you can look at this, be like, oh, Boolean, not assignable to example union, relatively easy to figure out. So I hovered over this, it was a little more complicated. I wanted to show you like, this is sort of what they start to look like as you start to grow a project with TypeScript and it gets bigger. So I'm going to get rid of this key. So something like this is a very typical TypeScript error message. So these sorts of error messages are very confusing. There are two quick things though, I guess I want to say about them, which is that like you get better at understanding them with time. And there's often this little code at the end. It's like TS2322 or whatever this is. If you plug this into your search engine of choice, it'll often be able to help you out and be able to tell you like what exactly you're doing wrong. But if you can't really do it that way, then typically like I kind of read this with like a stack trace. I start at the bottom, which is sort of like the bottom, like the closest to where you are. And then as you sort of work your way out, sort of like indentation sort of up, like to the left and up, like you sort of are getting like more and more generic. And often, like if you kind of work in that direction, you eventually figure out, oh, this type and this type don't match. And then you're able to like use that as a jumping off point to kind of where you need to sort of attack and figure things out. So all this is to say, these TypeScript error messages it's like an acquired art of learning how to read them. And you get better at it with time, but it still gives you a headache when like, because this is 2 levels. Imagine one of these that's like 30 levels deep, and you're probably like, that's crazy. But I saw one of those like a few hours ago at work. Like it's pretty typical on like big TypeScript projects for them to get that large, especially when you have like libraries involved and stuff like that. Okay. So anyway, because that showed up, I just wanted to mention that real quick. So after the break, we're going to talk a bit more about all these different TypeScript syntax oddities. And discriminated unions are next. And those are a really fun, powerful thing that is a nice headache inducer. So look forward to that. Max, do I have to come up with a secret word for this time around, or do you want to do that?
Yeah, secret word is TypeScript for tonight. So go ahead and fill out the attendance form. Secret word is TypeScript.
Cool. It's been a while, Max. Anything else I'm missing that I need to do before the break?
Go on break, be back at 7:35.
Excellent. All right. Okay, sweet. So before the break, we talked about TypeScript. We talked about what it does, what types are, and how one can use TypeScript to manage larger projects and keep track of complexity in a JavaScript code base. And then we started breaking down a bit of all the different ways you can represent complicated type situations in TypeScript. So I've got a few more to go through. I think realistically what's probably going to happen is I'm going to get through most of my list here. I'm just going to kind of keep going until Max tells me we got to stop. Or I run out of obvious stuff. So I'm just going to keep going. I said before the break, we are going to talk about next this thing called discriminated union. This is a pattern that is really unintuitive if you have sort of typical like typed programming language knowledge. And this is like has a lot of very weird little TypeScript things in it. Just part of why I want to cover it, because a lot of people, me included, when they first get into TypeScript, don't really know you can do this. And because of that, end up writing a lot of very weird and unusual TypeScript code. So I think this is a kind of a good summary to sort of show some interesting patterns that you should be aware of, and this just general sort of wider pattern as well, the discriminated union. So discriminated union. Okay. So a discriminated union is typically done in a type alias. So you sort of do like a type alias and do this sort of pattern. And what this does is allow you to represent a value that could potentially be slightly different versions of an object. a great example, I don't know if this is going to hit for anybody, but if you've used libraries or like tools like Redux, being able to represent like an action as a discriminated union, it's a very common pattern. Or let's say you have like a function that takes sort of like two sets of parameters. Something you might do is you might have it accept one parameter as an object, and that object be a discriminated union that sort of like is between both of those different types of objects. So what this allows you to do is sort of represent objects that can be sort of like variable forms as one type. So I'm going to do this as a type alias. Typically, how I see this done the most. So, discriminated union. As part of a discriminated union, you need to have. So I guess fundamentally, what this is a union of a bunch of different objects. So we talked about that above, and that's kind of what we're going to be writing here. We put in these objects is really important. Every object in discriminated union has to have one key in common that is set to be a literal type. So what do I mean by that? Well, let's just use like the type key, for example, and then let's have this be like hi or hello. This other one, we're going to be like type of foo or something. Not very imaginative with this kind of stuff. So this probably looks pretty similar to what we did up here. Pretty straightforward. However, when the discriminated union starts to become powerful, is I can add other properties in here. So maybe like type hello has like I don't know, like A number and B number. And then foo maybe has like C of string. I'm going to just indent this a little bit just to make this a little bit easier to read here. But fundamentally, this will do the same thing. Okay. So what we have here is this union of two objects. So the object can either be type hello, A number, B number, or type foo with C string. So sort of we have like two different ways we can represent discriminated union. Okay. Again, this probably shouldn't seem too crazy from what we've talked about before. However, how you use this has some interesting properties. So I'm going to make a function. Actually, wait, no, I'm just going to make a value. I'm going to call it my value. And this is going to be a discriminated union. And I'm going to set this equal to type hello A1 B2. Okay. So my value is a discriminated union. So it's sort of, it could be the value, my value here could be this or could be this. Now what we've assigned happens to be one of those, but the variables of type discriminated union, so it could contain either. So here's where discriminated unions get interesting, because TypeScript has some very unusual behavior around how logic statements affect types. So as an example, if I do something like if my value dot type is equal to hello, what you'll see here is inside of this, my value, it's able to know, because I said if my value type is hello, it's able to know, oh, inside of this if, the only possible case of our discriminated union that is like valid because of the if happens to be this part of it. So what TypeScript will do, and this is what's very weird in a typed language, is the type of my value will actually change inside of the block this if forms. So inside of this now, like I can act as like my value dot A, and like result will be a number. Like, if I didn't have this if here, like, oh, well, it's gonna do some fancy stuff because of the discriminated union. Okay. Give me a second. I gotta trick TypeScript into not trying to be smarter than it thinks it needs to be. I think that'll do it. Yeah, there we go. Okay. So TypeScript was able, I guess I should explain what I just did there. TypeScript was able to like look at this and be like, oh, actually, I know what type this actually is. This isn't a discriminated union. This is only part of it. But what I actually want TypeScript to be is like, this is a discriminated union. This isn't like a part of it. So because of that, like, because my value is a discriminated union, I can't access A on it because like A isn't available in all the different branches of that discriminated union. So if I want to access a branch of a discriminated union, the way you do that, and this is why you need that key that has that literal type in there. So what TypeScript's able to do is because you have this literal type here, it's able to use that to figure out, oh, this branch is the only branch that can be active inside of this conditional. And you can do this with more than just literal types. You can also do some fancy things where like, if something's like a string in one place and a number in another place, you can sort of like hinge off of that too. But that gets a lot crazier. And frankly, I kind of avoid that because it just gives me a headache. So if I put this back here, my value dot type is equal to hello. Now I no longer have that red squiggly line. So this sort of pattern of having a union of objects that all have a literal key within them is very common when you want to represent some sort of data structure that has multiple different forms. And maybe you want to like pick one that you want to give to it, but you want to have like one standardized whole that sort of both forms fit into. And then when you want to handle that discriminated union to be able to unpack it and pull out the specific forms you need, you can use conditionals, and TypeScript will understand that you are only in one branch of that discriminated union and change the type of your variable on the fly. Now, also it's worth mentioning that down here, my value now discriminated union again. So it's only within this branch that it's different because of the type, or the conditional, excuse me. Okay, so for anyone who has typical type programming language experience, probably seems weird, I would imagine. But overall, any thoughts on this? Does that make sense? Cool. This is probably the most common pattern you'll see, but there also are some other patterns too that sort of use this kind of feature of like being able to analyze the conditional to sort of change the type inside of the conditional. To maybe like answer some questions that folks might be thinking. This tends to be pretty hard to break in that like TypeScript has a pretty good understanding of how all the different conditionals work. So like this works with like a switch with an if. I'm trying to think what other sort of conditional cases there are. But like it sort of, it's hard to break, and it's also able to like understand logic properly too. So if I have something where like I do like my value dot type is hello and my value dot a, and now it's like, oh, a is a thing in here, and it knows that because the first part of this evaluated already and had to be true because of the and so therefore the second part, like now it knows that we're on that part of the discriminated union, and now I could check to be if it's like 1 or something. You can also, so I mentioned, also do this with other sort of checks on those types. The other one I actually tend to use probably more than I should because it's probably kind of confusing. If you have something like string or number, I do like, I guess it'd be like const u union is 1, 2, 3, or I guess foo, or something like that. Something like this also works. Type of u is string. And now it knows within this block that it's a string. It's like that side of the union. So like type of here, this sort of construct in JavaScript that you can use to determine the type of values, like TypeScript sort of understands that too. And there's a lot of things, a lot of sort of built-in language features it's able to understand and use to sort of properly figure out the types inside of the blocks like that. I will say a few things that don't work that are particularly that I wish did. The one that I run into the most is if you have like, let's say a value and you want to check if it's in like an array, a very common thing you might do is like, this is an includes method on an array. And like check to see if like, I guess, how would I do this? Well, I don't know. I'm not going to try to write it out, but effectively this kind of includes check or like methods. There's a lot of methods like this that are sort of like not built-in language features that sort of don't work with TypeScript properly. So there's a real challenge often when you're writing TypeScript where you have to sort of pick ways of doing things, not necessarily because they work or they don't work, but because they're able to make TypeScript happy or not make TypeScript happy. So like, for example, like if you wanted to check, like see if like an item's in an array and then use that to hinge off of like what the value or something like that. Yeah, I guess that's what I was gonna do. So yeah, let me actually try to write this. I think it'll maybe make more sense. So if I did like like A, B, C, D, or something like that. So like in this case, I would expect that like blah inside of here. Oh, wait, maybe it is smart enough now to do that. Or oh wait, no, it's because TypeScript's being too smart. Let's try to, yeah, there we go. That's what I expected. Okay, cool. So like blah here is like, it could be one of these values. And then I'm trying to be like, is this in this array? And it's not smart enough. Like you can see here, it's still got all of them in here, where if I were to update this to instead be something like blah is A, it would be smart enough to be like, oh, that's just A. So there's a lot of stuff like that where you have to sort of pick ways of doing things sometimes that make TypeScript happy. Like, even though like these two lines here, that line and that line might be equivalent, like the second line is going to make your life with TypeScript a lot easier. Because if you were to use this and you need this to be as type the string A, you then have to like type assert it or do something fancy to get it there. And typically that's kind of like a code smell of TypeScript. You want to try to avoid that and use all these like language conditionals to sort of like narrow your type to be exactly the thing you want. So this is very weird. I keep saying that because like this is behavior where I didn't realize this. No one ever told me this when I started writing TypeScript, and I wish someone had, which is why I'm saying it now. Like, you are meant to rely on this stuff, and if you don't, you're going to have really hard time writing effective TypeScript. Okay. Any questions about discriminated unions, how all these like conditionals like narrow types and things like that? Okay. What do I have next? Okay. Yep. Yeah, as const. Okay. I think we're going to do as const. We're going to talk a little bit about how you use libraries in TypeScript because that's kind of a pain in the ass. And then we're going to, if we have time, maybe touch on generics, but I really don't want to go too far down that rabbit hole because if anyone's heads are exploding already, that's going to really make your head explode. And then I think we're going to talk about like my thoughts on TypeScript, and then probably we're done. Okay.
Hey, Ryan, it may be a good idea to do like the skip to the pros and cons now,
because students may have questions about pros and cons and like putting
Yeah.
all of this in context. And then if we have time, jumping back to the last of your list.
Sounds great. Okay. So I have a lot of thoughts on TypeScript. As I said before, I've used it professionally for probably around 5 years now. And I've used it on a number of different teams. So teams where mostly junior folks, teams like a mixture of junior and senior folks, all senior folks. And I found that it's really interesting because how well TypeScript tends to work really, like, it can really vary a lot depending on the project and the team. I want to talk a little bit about that because some of you, I imagine, are probably going to come out of this presentation and say, I should use TypeScript on my capstone. It would be a great idea. And this is the part of the presentation where I'm probably going to tell you shouldn't. I'm going to explain to you why. Not to say you like can't, but that I probably would recommend you shouldn't. Okay. Let's start though by talking about some of the pros. So if you've noticed when you write TypeScript, in the act of defining all the types, you end up doing a lot of planning. You have to think a lot about how your code's going to be structured and where certain data is going to live. You have to sort of think through all that. Because of that, often the code you get on the other end after you're done ends up being a lot more robust and makes a lot more sense. And of course, code that makes a lot of sense, that's good, easy to understand, and also like it's way more maintainable. So it's like kind of a good long-term thing, especially for a project that's going to live for a long time. Another benefit is if you have lots of people that are all contributing to the same code base, so lots of people will be all touching the same GitHub repository, it allows different people on that team to all easily make changes to that same shared code base. So keep in mind, most of the work you probably have done so far, you've been working on changes on code that you've worked on in the past. So you wrote it, you're then modifying it. But in a professional context, I would actually say it's probably almost more common for you to be touching code that you didn't originally write, having to understand how it works, and then make whatever modifications you have to make to it. So anything that can be done by the last person to make your life easier can often be a real benefit in like your speed and your productivity and also your ability to write less buggy code. Because you don't know how the other person, like what they did, how they assume things to work. So therefore, like you don't have all those assumptions in your head. And when you want to like try to extend their code, you're just kind of trying to figure it out as you go along. And something like TypeScript makes that more explicit, makes it more clear. Oh, this is how someone intended for this thing to be built. And then like if it's not your code, like that's really good. So I guess the last pro I wanted to mention, these are just kind of off the top of my head. If you use tools like VS Code, there are things built in like what they're called IntelliSense or whatever, these like fancy editor features that are able to look at TypeScript and use that to sort of like better understand your code as a computer, and then to be able to give you error messages and like provide extra editor features. So a great example, you've seen that in VS Code, I've been like hovering over things here to like see types of things. That's a great example of like the kind of thing that like these behind the scenes technologies power. Microsoft's brand name for it is IntelliSense. If you hear me say that, that's what I mean. But these sort of like features, that's sort of powered by TypeScript because that type information has to be like determined somehow. And that can be really nice. Actually, I'll say one other feature that is kind of nice too is like, I don't use VS Code a lot, so we're going to see if this works, but I think, yeah, here we go. Rename symbol. So there's this thing where I can actually go into here, and because TypeScript's able to trace through where all the variables are and like all the types, I'm able to be like, rename this to be like my crazy variable. And it's able to go through and update all the location of it properly and sort of like allow you to have these like kind of neat refactoring tools built into the editor. So sort of some people like them, some people don't like them. I will be honest, I happen to be on the mostly don't like it side, but that's apparently like kind of most people don't react that way. Most people really like these tools. So it's a pro for a lot of people. Okay. Those are kind of my pros. My cons. So I have worked on a number of teams where TypeScript has been introduced, usually by one engineer who's like really into it. And this is like maybe let's say like a team of like 3 or 4 people. And then you have one engineer who's like really into it and is like, we should use this. And then maybe like they get like 1 or 2 other people on the team into it, and other people are like, yeah, I like this. And they sort of drag the team into using it. And what ends up happening is it ends up like you end up putting it in the project, and then those engineers who don't really use it or aren't really into it or don't really understand how it works, it massively slows down their velocity. You end up spending a lot of time just fighting TypeScript, often more time than you actually spend writing the real code. And as someone who's getting started with this stuff as a beginner, that is really discouraging. It's also really discouraging when you have deadlines and you're being asked to build this thing using this tool that you don't really understand, and you don't really see the value in it that much. So you're just like, whatever, I don't care. I'm just going to like do the minimum I have to and get it out there. And that's when sort of like any start sneaking in all over the place. Fundamentally, I think TypeScript is most effective as a tool when everyone who is on the team has at least some amount of familiarity with it, and it's not going to measurably slow down their productivity. That's like the first thing. And also, the code base is large and expansive enough where tools like TypeScript actually provide a significant amount of value as compared to the amount of mental overhead you have to use them. So it's a tricky thing. And this is why like I really wouldn't encourage most of you to use this in your capstone. Like it's a cool technology. Definitely play around with it if you want. But what almost certainly is going to happen is you're going to get into some crazy type situation. You're going to get stuck. You're going to spend a lot of time on it. And like it might be worth you to learn it and figure it out. But I definitely think that at this point in most of your sort of software engineering journey, there are more important things for you to be focusing on that are a higher priority. And that's kind of, to me, like the fundamental thing. Not that it's not a useful tool, but that like you really got to have a good handle of JavaScript and how everything works before you add one more layer on top of things to be able to like debug and troubleshoot. Yeah, I kind of just said most of this, but like the teams I've been on, their TypeScript has not gone well, have like been very junior leaning, and very like folks who like are often willing, like don't have the bandwidth to put the time into using the tool properly. The teams I've been on where it's gone well have been usually senior leaning. Usually everyone has a pretty good handle on the tool and is able to use it effectively. And it doesn't really provide that much of a slowdown generally for everybody. So the benefits end up outweighing the costs. Overall, and this is kind of controversial, but this is kind of my opinion. When I'm starting a project, I don't usually use TypeScript. And as like a senior engineer that is in the JavaScript world, like that is a very controversial opinion these days. I don't think it is, but it is. And so like I typically don't start a project with TypeScript. If it's something that I think would be helpful later on, sometimes we'll add it in. But like, especially if it's something I'm working on myself that I can kind of keep it all in my head, it ends up to me often being more of a cognitive burden to have it in there. Now that starts to change a bit, like when you have other people involved in the code base, and maybe gets a little bit bigger. But yeah, so that's kind of my thoughts. Anybody have any questions on that, or if you disagree, that's great too. I'd love to hear your counter argument. That goes for you too, Max.
I am in the anti TypeScript camp usually, right? And I will you know, Ryan and I have similar number of years of experience professionally, right? We've seen it in different teams. I was snickering when you said there's always the one diehard fan that's like, you know, oh, TypeScript is awesome, and like how it's so dumb of you to write code if you don't use TypeScript. Like everyone should use TypeScript. And the answer is that it causes a lot of overhead, right? And there is almost I think a peer pressure in the industry, right? To be like, oh, TypeScript is better. So because it's better, everyone needs to switch over to using it. And so I have joined teams, been doing contract work that uses TypeScript. And we have actually missed deadlines because being able to work quickly enough in the code we weren't able to achieve that because everyone was getting over the learning curve of TypeScript. So I think it really depends on the company, right? If you're going into a company and they're like, oh, we all use TypeScript. We made the switch over years ago. Every project we create is using TypeScript. Then that's like a no-brainer, right? Of like, okay, I need to learn TypeScript and I need to use it and run with it. But from what I have seen, other than the diehard people who use it, what Ryan has touched on of like, people just start throwing any in every place that they can to just shut up TypeScript, right? And it kind of starts to get away from you and you lose all of the benefits of it. So I have heard the argument used relentlessly of like, it's always backwards compatible. And then you go to submit your code and it's like, no, they're TypeScript errors. We refuse to accept this. And it's like, that wasn't how TypeScript was meant to be used. So you know, even though I understand it, I don't personally use it. So that brings up the major question of like, why are we teaching this to you, right? Why are we spending an entire night on this in the curriculum? Well, it continues to get more and more market adoption, right? And I think more and more companies are starting to use it. And if you get over the learning curve of how to use it, it can benefit your project. But at the same time, you don't want to let that one diehard fan come in and be like, this solves all of my problems. And so I would say my biggest problem with TypeScript is I've been writing JavaScript code for 10 years. And I think once in my 10 years of writing code, did I hit an error where I went, oh, if I had that variable typed, I would have been able to find that error quicker. Is that one error in my 10 years of writing just the type of code that I write really worth dealing with union intersections and typing every variable and thinking all of that stuff out? No, probably not, right? But it is something, again, that the industry is slowly but surely rolling their way over, and why I think it's important to spend the night on.
Yep. Max and I definitely are of the same thoughts on this. I will say that if you do get into this, though, keep in mind that you might become that one diehard fan on a team, and be aware of that dynamic. So, like, I guess that's all I would add on top of what Max said. Yeah. Okay, I got one more thing to say too. I think this is more just my opinions. I think there's a real like problem in the industry where people often point and say, this is the solution, when really, like, it's better to realize that everything has trade-offs. And there's never really like one right or wrong solution. There's sometimes there are better and worse solutions, but more often than not, the solution you pick depends on a lot of factors that are often hard to quantify and often are not technological. Things like the team, things like the amount of time you have to put into the project, or like the size of the code base. I think this sort of dynamic that Max was touching on, I've been on a lot of teams where that there's a lot of focus on people looking at somebody else and being like, we should do what they're doing because of insert whatever reason they want there. Sometimes that can make sense, but sometimes it can't. And I think like what's really most valuable, and something you sort of will develop as you become more in-depth in software engineering, is realizing what technology choices make sense and what don't, and how that can change with time, both like depending on like things like as the code base gets larger, things like what new technologies that come out, but also things like just someone like gets fired or leaves the team, and now all of a sudden like things that used to make sense no longer really make sense because they're not around anymore. So it's a very nuanced problem, and anyone who's just like, we know the solution, use these technologies, like they're missing some key bits in their decision making, and you shouldn't be like just going along with what they say. So yeah. Okay. So Joe, you have a question. It's kind of off topic. I do want to answer it though, because I think it's a good question. But I'll answer that and then I'll get back to what I was talking about before. Unless anybody has any questions on what Max and I talked about. I do want to give some space for that. Cool. I would say if you do end up going down the crazy rabbit hole and do use TypeScript in your capstone, good luck to you. And I mean, if you send me a type problem, I might be able to help you, but I might just be like, I don't know. So I think Max probably would say the same. Okay. So Joe asked, if precision is difficult due to floating point accuracy, then what do developers usually do for online transactions? They use a different language to handle that? Do they do what you mentioned and make a floating point engine? So I mentioned fixed points. So I guess, again, this is a bit off topic, but like typically the floating point numbers have precision problems. So floating point numbers being like the way that numbers are represented in JavaScript. If anyone's curious, I guess this is more of just me talking to Joe at this point, but I'll make this quick. Like, if anyone's curious, like you can look up what that means, or I can maybe go into it a little bit more in depth. But like, they have precision problems, and if you need numbers to be at a certain precision, either you have to use number types that are designed that way, or you have to do everything in a fixed point way. I actually was just working on a product like a few months ago that had like some, like actually like a month ago, that had like some very important like decimal precision types of problems. What we ended up doing to solve that is we did all of our arithmetic in the database, and then at the very end let it round when it gets sent into JavaScript. And because we did it that way, we only had one place with accumulated error, and that was good enough for our use case. But if you accumulated error is not okay, then you have to do everything in fixed points, and you have to do the conversion at the end, do the division. So yeah, just kind of the crappiness that comes with having not good number types. Hopefully that made sense. Okay, let's back on topic. And Joe, if you have more questions like this, feel free to DM me in Slack. Like, I've had to do a lot of this particular topic. I've had to do a lot of thinking about in the past few months due to this project I was on recently. So, okay, back over to TypeScript syntax stuff. Let me make value. There we go. Okay, so I was next going to talk about as const. So, let me see if I can. This is another one of those where I'm gonna have to try something and make sure I get the exact incantation here perfectly right to be able to explain this. I guess I needed to be like, uh, yeah, there we go. Okay. Actually, makes me think of one more thing I want to cover too. So if you notice with this value here, TypeScript defines this. It thinks the type of this is an object with a key inside called type, and the value being a string, because foo here is a string. That's great. The challenge, though, is sometimes what you want is you want this to be the literal string foo. So kind of like something like this. You could imagine what this would give you. Okay, or maybe that's not going to work. Why doesn't that work? Oh, yeah, because I didn't do that right. I mean it like this. So like, okay, yeah, I guess it's a little bit contrived, but like you sort of want to be able to be like, I want this literal string foo here, here. I don't want this to be string. I want it to be like foo, like this. I guess that also works too. Okay, that's better. So how do you do that? Well, one thing you can do is you can just explicitly define the type like this. However, that's not always possible or easy to do. There's another way you can do this. It's worth knowing about. This is sort of like another one of those like little weird TypeScriptisms. If you ever have a value where it's being interpreted as like a generic value, and you want to make sure it's as its literal value, after the value, you can put this thing as const. What this will do is it will make it into the literal string or the literal value. So just go back and forth there. Type string, and if I do the as const, now that's type foo. So it's a little thing, but that is really handy sometimes. It can make certain problems like way easier to solve. So I just wanted to mention it because that's another one of those things where no one ever told me it for a while, and once I learned it, I was like, oh, okay. A great example is sometimes keys in a discriminated union are for some reason considered to be a string. So often when I make a discriminated union, it'll actually stick as const after that key just to make sure that it's right. And why is it? Okay, I don't know what's going on there. It's doing something funky. Oh yeah, yeah, that's right. That's because it as const you use in a value, not in a type. Forgot about that. So as an so you wouldn't do this because this is that. Like it's just like the literal string foo is the literal string foo in type in the types. But in a value context, and like the thing you assign to the variable, in that case, it's kind of ambiguous whether this should be a literal string or the string like string, like this kind of string. So that's how you resolve that ambiguity. Okay. Any questions about as const? It's kind of small, but it's good to know about. Okay. Did I have anything else here before talking about generics? I didn't. Oh yeah, there was one other thing I wanted to talk about. What is this called? I guess like type like plucking maybe. I don't know what this is called. There's got to be an official word for it. But another sort of interesting type arithmetic kind of thing you can do is if you have a type, for example, let's say our discriminated union type up here. Discriminated union. Something like that. So you got our discriminated union type. And let's say I want to be able to access like a value in that type. So like this is the type's like an object. So let's say I want to maybe get like the type key from this. Just like you could in JavaScript, you can actually use sort of like the bracket notation to access that value of that type. Actually, I guess I should do it like this. And if you do this, what this ends up becoming, you see how this is now like the union of hello and foo. So kind of explain that. It's like accessing the type key within both of the branches of the discriminated union. And it's able to say, oh, hello is one of them, foo is one of them. And it's able to sort of do the math and be like, oh, okay. So what you actually mean here is that the key from that. As like a simpler example too, like if I have our example union bit up here, if I did like this and then did like hello. So in that case, like hello world, A, B, Y is now world. So there's kind of like a few different ways you can do this. But the reason why I want to show you this discriminated union one is this starts to touch on a bit of where TypeScript can get complicated, because this is the kind of thing where what it's doing is more than just like super simple, easy to follow in your head. Like what it's doing is it's like pulling out keys and values from the parts of the discriminated union. And that results in some like more cognitive overload of like trying to understand what it's doing. You can imagine if this like got like 2 or 3 levels of this deep, like you could start to get into some more complicated like cognitive situations. So yeah, I should know what this is called. I don't know what this is called, like object accessing on types, but it's another one of these things where like it comes in handy sometimes to be able to like take a type and to be able to access a sub area within that type. It's like its own value. Okay. I want to talk about quickly about how you deal with libraries in TypeScript. And we'll see how long that takes. And if I might touch on generics, but I don't know if I want to go down that rabbit hole. Okay, so thus far, all the code we've used in TypeScript has been in this one file. We haven't had to use third-party libraries intermixed with our TypeScript code. This can be a real challenge because if you think about it, all of the type information we've defined for TypeScript is within this file. If you download like a third-party library from, let's say, NPM, that package won't be written in TypeScript. It won't have type information. So you can import potentially like whatever you want from those packages, but they may not have type information, and therefore you may not be able to like actually use them. Like you'll like be able to import it, but just like the type will be any, and it'll just be like, oh, okay, well, there's no type information for this. So how this is actually handled is a little bit dependent on what tools you use. But in a lot of more primitive tools, I think Create React Apps this way, you can use things that don't have types. It's just or don't have like type definitions. When you import them, they'll just be any. So imagine when like we had some sort of crazy library, I install it, I import it. The type of that thing that I import is just going to be any, and then I can't do, like, I don't have any TypeScript magic on it. I can pass anything into it. I can get anything returned from it, but any comes in, any comes out. And if I want to convert things to sort of like types to use in my code, I've got to type assert them as whatever custom type I want. So I have to sort of do that like custom type to any, and then any to custom type conversion coming in and coming out. I'm not going to do a demo of that because typically that's not how you're supposed to do it. I want to show you how you're supposed to do it, but I just want to let you know you can do it that way in some cases. So the way you're supposed to do it is TypeScript has, well, it has some ways where it can actually inject types into libraries. And as an example here, we're going to pull out a library that I'm actually using at work right now. And the only reason why we're using this is because I happen to know it doesn't have types included in it. It's just one that I know will work in this situation. There are tons of libraries that have this problem. But yeah, so I'm going to install this package. It's called Papa Parse. It's a weird name. What this package does is
Their documentation is so on point, though.
yeah, it is pretty good. Okay, so you've used it before. I'd never encountered it before. I've always used other CSV parsing libraries, but it's a CSV parsing library for JavaScript. If any of you don't know, CSV is like a tabular data format. If you make data in a spreadsheet program, you can export it to CSV, and it's sort of like a text representation of that spreadsheet. It's a very helpful format. So I'm going to take this package and I'm going to install it. So npm install save Papa Parse. And I'm going to quickly over to the documentation just so you can see how they should use this. Okay. Okay, they're not going to give you exactly what I was looking for. Whatever. We'll just make it up because I know how you should use it. I actually need to start this back up over here too. Okay. So I'm going to go back over to my code editor here. I'm going to go import Papa from Papa Parse. Papa Parse. Okay. So what you'll see here is a few things. You'll see the red squiggly line under Papa Parse. But before I start to do some stuff with it, I want to show you that if I try to use Papa, you'll see that this here is I don't have any sort of auto completion. It's effectively an any type. I can't do anything with it explicitly. And the reason why is because Papa Parse is written in plain JavaScript. Because of that, there's no type information about it. So Typescript doesn't know how to actually use to get that information. You hover over this, it's going to sort of tell you a little bit about maybe how you could solve this problem. So could not find declaration file for try this command here if it exists to add a new declaration file containing whatever. So it's using this phrase here, declaration file. And this is a very important thing to understand in the TypeScript world, but is also very confusing. The best way I can explain it is for those who have familiarity with C, probably read Joe, but maybe others too. A declaration file is like a C header file. So it is the kind of thing where you use it to sort of outline the input and output types of your data, and it's type specific. And the way that TypeScript works is if you have JavaScript code, you can define a file near that JavaScript file with a .d.ts extension. And when you define that .t.ts file right here, that sort of allows you to define overlaid on top of your JavaScript file what the type should be in that JavaScript file for everything that it exports. So as an example, well, actually, I guess before I get into that, these d.ts files, there is a repository of them managed by the Microsoft people that is in this repository called definitely typed. I think it's TypeScript. Is that right? No. Okay. Definitely typed. Yeah, this. Okay, I guess it is under TypeScript, but so what this is, it's just a community managed repository of type definitions for NPM packages that were not written in TypeScript. So what you can do is, inside of here, you can go in this types directory, and then inside of here, you have like literally like a directory for every single package that someone contributed type definitions for. So I'm going to actually, I guess I'll do it this way. I'll go to this one, and then I'll go papa parse. So you can see here, these are the papa parse type definitions. And this is actually a little like NPM package. So I've got a little package.json on here. And you can see each of these packages, it has a @type / the name of the package. And that's sort of the way all this definitely type stuff works. Inside of here, there's a index.d.ts file. And what this does is this defines all of the type definitions required for papa parse, for all the things it exports. So it looks like there's a bunch of different versions of this parse function that are all included. That all sort of like, there's one version where like URL is a string, that's the first parameter. Config is this sort of parameter here, which is a type alias that is, I think, defined below, if I remember right. Looking at this earlier today, so we'll see how my memory works. Yeah, here we go, parse config. So like, this is like a type sort of definition here, or type alias. And we've got inside of here a bunch of keys that sort of are mapped to, so you can start to see here how like, this is some real TypeScript code. It starts to get more complicated than some of the contrived stuff that I was putting together in VS Code. There's some comments here explaining what all this stuff does too, which is kind of nice. But what I'm going to do is I'm going to pull in this definitely typed package. So I'm going to come over here and I'm going to run npm install save types papa parse. So this @types prefix thing, what I'm doing is by adding it to papa parse, I'm now going to pull in this definitely typed package. That's sort of a community created package. The people who made @types papa parse are unrelated to the people who made papa parse. It's like a different sort of group of people. And now that I've pulled this in, you'll notice the red squiggly line went away from papa parse. And now inside of here, if I hit dot, I've now got all this stuff defined in here. And what this is all coming from is from the type definitions that I just installed. So, like, and I hover over this, and it gives me all the gives me all the fancy editor stuff that people who like that get. And also, like, I can go here and do go to definition. You'll see it'll jump and actually show you here in line. We have the types papa parse package. It'll show you sort of like the type definition it's using. So the biggest weirdness about all this that really threw me for a loop the first time I had to do all this is like that @type / thing. It's just like a magic prefix that TypeScript happens to know. Like the TypeScript people, the definitely type people are the same people. Like they just sort of like, it's like a first party representation of all the types that the TypeScript people have put together. And there are community folks that will contribute to it, but fundamentally, definitely typed is like a Microsoft TypeScript project. So because of that, they just have like built in that if you install an @types package, it'll just work. And it's just weird, and you just have to know that's how it works. But that's just how it works. So yeah, I guess I've given you sort of the long way around it here, but the summary is, if you want to use a package in NPM in your TypeScript code, and it doesn't have type definitions already included in it, then you're going to need to find those on definitely typed. And the vast majority of popular packages have already had them created. And then install those. And once you install those, then you'll have all the typing stuff working properly for your package so that you can use it in the TypeScript ecosystem properly. One more thing I want to quickly cover on this, which is if you don't have a definitely typed implementation for your package you want to use, then there's a way you can, I guess you could contribute to definitely type. That's one option. So you could like write your own types and give it to them, and then they're available for everybody. There's also another way you can inline define types, like effectively like define an inline version of that .d.ts file, the sort of like monkey patch the types on a thing that don't have them defined. I'm not going to talk about how to do that right now because frankly, I don't remember how to do it off the top of my head and I have to look it up. But it's possible to do that, and it's something that I've had to do in the past. So, yeah, using libraries in TypeScript is like can be really complicated. And also keep in mind that like once you include these libraries, they start to have some more complicated types in them, and it will exponentially make your TypeScript errors more complicated. So like if you like as just an example, like let me call Papa Parse wrong and see how, yeah, here we go. This is a great example of the kind of thing you run into. Let me just bring this up here. So like I look at this and I get very overwhelmed. And probably most of you do too, maybe except for Joe. But what this is happening here is like I'm getting this error because the first parameter of Papa Parse doesn't accept a number. So like I see that here. But you sort of have to like dig your way up and down to sort of figure out you have to figure out like where in that error you actually have to focus on. But just because I've been doing this for a while, I happen to know that like that's kind of where my eye goes. Yeah, anyway. I think we're kind of probably about at time here, and I don't know if I want to go that deeply into generics because that'll be a whole thing, and yeah. However, if anybody wants to go more deep on this, and like I will say TypeScript's documentation on their website is pretty good. TypeScriptlang.org, they have a whole doc section of it. So feel free to go through that. And I'll also say that like the best way you get better at this stuff is just by doing it. Kind of like with anything in software, but I'd say especially TypeScript, like you run into crazy errors like this. And this isn't even that crazy of an error. Like, but like you run into like complicated errors. And the only way you really figure out how to fix them is just by like encountering them, bang your head against the wall for like hours, and then eventually figuring out, oh, that's what that means. And you do that like a bunch of times, and now all of a sudden you kind of know what you're doing. So the only thing that separates like me from you is that I've just put thousands of hours in solving type problems at this point. And yeah, so anyway, Max, is there anything that you think that's worth talking about that I haven't talked about that's like important TypeScript stuff?
No, I think you hit all the key points.
Okay, cool. Sweet. Well, I think then I'm going to take what I have here. I didn't do the VS Code live share thing, and in hindsight, I probably should have done that. I'm going to take this. I'm going to paste it in Slack just so everyone's got a reference to it and can refer back to it if need be. I guess just as like a final thing, anybody have any questions on anything TypeScript that they just want me to answer? I can try. Cool. Okay, easy for me. Sweet. Well, I think that's pretty much it then. Yeah. Good luck to you if you want to try to use TypeScript on your capstone. I don't recommend it, but good luck. And yeah. I'm forgetting, Max. Is there anything else I'm teaching after this, or was this my last official thing?
The last one you have on the schedule, but we talked about doing like more advanced modules, so
Oh,
I'm
yeah,
not letting
that's
you
right.
off the hook yet.
Okay. Cool. Well, you might see me again, folks, but at least for a while, this is That's it.
Oh, you're coming back for authentication.
Oh yeah, I forgot about that. That's like end of August?
Easy enough to give you that answer.
Okay.
That is, yes, August 27th and 28th.
Okay, so you got a few weeks, and then I'll be back for a few days. Cool. That's all I got, folks. Yeah. Have fun, try TypeScript out, and hopefully see you soon for authentication.
Thanks, Ryan.
Yep.